Hello, everyone, and thank you for joining us. My name is Juliet, and I will be the moderator for today's webinar. Before we dive into the content, let me cover a few housekeeping items. At the bottom of your screen are multiple engagement tools you can use. All tools are resizable and movable, so feel free to move them around to get the most out of your desktop space. You can expand your presentation area or maximize it to full screen by clicking on the arrows in the top right corner. If you have any audio or video issues, you can find answers to some common technical issues located in the Help widget at the bottom of your screen. Please note that a copy of today's slide deck and additional resources are available in the resource list. Please have a look and download everything that you may find useful. Also, the webinar will be recorded and sent via the email you registered with. Lastly, if you have any questions during the presentation, you can submit them through the Q&A widget. We're here to answer you live via the chat, so don't hesitate to reach out throughout the presentation. Now, I'll give you a quick intro of our speakers. Today, we're joined by Chris Unger. Chris is the retired Chief Systems Engineer for GE Healthcare. He was responsible for the definition and improvement of systems engineering process globally. He is a member of the Chicagoland chapter of INCOSE, the co-leader of the INCOSE Healthcare Working Group, and the co-founder of the Systems Engineering and Healthcare Conference. Chris has worked as a systems engineer in the defense and medical fields for 40 years. He graduated with a BS in mathematics and a BS in philosophy from MIT and a PhD in physics from Boston University. Currently, Chris is the principal at PracticalSE, LLC, a systems engineering consulting company. We're also joined by Vincent Valgos. He is the Director of Medical Device Solutions at Jama Software, bringing his extensive expertise to the team for over 2 years. Before embarking on this role, Vincent spent a remarkable 17 plus years as a systems engineer in the medical device / IVD industry, playing a pivotal role in product development. His wealth of experience has made him a valuable asset in shaping and enhancing Jama Software solutions for the medical device sector. And with that, I'll pass it over to you, Chris.
Thanks, Juliet. So we're going to talk today about systems engineering in medical industry, for particularly medical device development. So the medical device industry faces several challenges. There's clearly constant time pressure in developing and launching safe and effective products. We've got to be faster than the competition with better products. And as you can see from the statistics, this is a challenge. Part of the challenge is in delivering things on time is the shifting regulatory landscape. I'm sure everyone's aware of MDR. There's software as a medical device. The FDA is going to think about redoing design controls next year. When we were at GE, there were like 8,000 regulations we had to monitor. So it's a very challenging and shifting regulatory landscape. Not only do you have to be compliant with regulations, you got to make sure that your device is safe. And so quality issues, safety, and just key performance are a key element of delivering on time. And that's getting more and more expensive. As you can see here, billions of dollars of financial risk of getting this wrong. So to make it all that harder, there's a constant increase in complexity. When I came out, there were typical software development teams were 20 to 40 people. It's now hundreds of people and lots of interactions. So additional things like AI and machine learning or new technologies. So you really have to manage a lot of complexity inside of your devices. And the organization structure is getting more and more complex. There's a heavy focus on acquisition. So you're integrating new teams, new cultures, geographically distributed development teams. So that makes it all challenging. So we're going to talk about how systems engineering can help address some of these particular challenges. So as I mentioned on the prior page, a key differentiator is getting to market faster. So the success of a program in a market-driven environment is basically profits. The first mover tends to collect the lion's share of the profits. We typically have many customers. You don't have a single customer. Marketing and product management tells you roughly what they think the competition will be and what differentiates. Versus in a contract-driven environment, success is satisfying the contract. So like within GE Healthcare, the avionics and oil and gas businesses typically had a single customer. Like we would produce a floating city block to British Petroleum or Shell, go to the North Sea or the Caribbean, and you had a contract and you delivered to that contract. Versus an engine, an aircraft engine or a medical device, we deliver to the marketplace. We decide the timing, we decide the features. So the stakeholders in market-driven are internal to the business, and you can negotiate budget and time. If you get a really, really cool feature, you can take an extra month or quarter to develop it. Versus in a contract-driven, it's really fixed. So the challenges of market-driven and contract-driven are different. With contract-driven, requirements are a key commitment. You've got to negotiate a formal design control. Versus within a market-driven environment, they're critical. You have to deliver validated requirements, but they are definitely an internal business tool that helps communication across all the business functions. So what's the value of systems engineering in a market-driven industry? We basically turn the ambiguous needs that we get from product marketing or product management and turn them into clear and feasible solutions to be implemented by the hardware and software teams. The key value we produce is that those implementations seamlessly integrate into the customer's workflow and work systems. So they work really well day one. They reliably meet their needs. So they work really well after 5 years. And not just meet their needs, they delight the customer. We really want to deliver something that the customer enjoys using. So we have to make it work day one. We need to make it work day 50. We need to make it work for every single customer. So you have to deal with all the known variability of hardware and process. Every installation, every service event has to produce a uniform, high quality, high performing product. So with those constraints, we want to optimize the business value. So when we have multiple options, marketing will tell us the customer value of these options. The implementation teams will tell us the delivery and product cost of those functions. The role of systems engineering is to make trade-offs between those and really optimize the business impact based on the cost of implementing. So we want to make sure the work done by those implementation teams is tied to the maximal market impact. And associated with that is managing technical risks. If you go down a path and it turns out to be infeasible, while it might have been nice if it worked, you just wasted a lot of that work. So that cost has to be scaled by risk. In doing all those first 4 bullets, our key value is making sure design decisions are identified and closed predictably, that the team acts with one voice. So decisions are framed, the options are agreed to, the decision criteria are agreed to, and the final decision is closed and stays closed as stakeholders change. So once you have a frozen design, you want to make sure that it actually integrates easily. And when you have integration or quality problems, they're found early and resolved early when you have time to react. It's a lot easier to adjust your design in the first half of your program. It's really hard when you find severe quality issues with a month left before shipment. And so really winning products happen when systems thinkers are effective. So clearly there's going to be a need for some systems engineering process excellence, but they're system thinkers across the entire program. And so we want to make sure that everybody is involved in systems and that the creativity of the entire program is maximized. So getting specific to GE Healthcare, what is systems engineering at GE Healthcare? Well, we have the essential customer perceived performance. So a lot of our programs are imaging. So we have the image quality, but we also have things like maternal infant care, where we deliver is the right humidity and temperature around the neonate. In delivering that essential performance, you've got to make sure it's safe, and you got to make sure you have regulatory compliance. As I mentioned, we really want products that are easy to use and delight the customer. So usability is a critical part of systems engineering. And in doing that, we make sure we define the right implementation requirements, the right reliability strategy, and it can be installed and serviced properly.